So, as you may have heard, my name's Connor Martin. I was previously at Uniswap while we developed the third version of the protocol, Uniswap v3. I worked on a number of projects involved with that, including the development of the Oracle library, which I will show to you in a second. Now I'm working on something that's not DeFi, Medallion, which is a protocol built to support musicians. But we're here to talk about oracles, which is my second favorite subject. Currently my favorite right now. All right, so initially this talk was going to be about price aggregation, but it turns out that that's quite difficult to do, right? There are many prices to be found on chain. There are not many prices to be found that are derived in the same way. And you can have one price that's aggregated with another one, but if they're found in a different way, or if they're created in a different price environment, or let's say like liquidity environment, you can end up in a pretty bad situation. So we're going to talk about aggregating Uniswap Oracle prices. Let's see if I can figure out how to do this. Okay, so a very high-level, brief overview about Uniswap v3. Prices are expressed and stored in Uniswap v3 using ticks, right? Ticks are demarcations in price space that serve as boundaries for liquidity. I'll talk about this in a second a bit more. And how prices or tick history or current tick data is stored or written, let's say, how it's formatted and how it's retrieved, end up being quite important in the terms of effectively querying oracles. So, let's move on. Ticks. As I said, boundaries between discrete areas in price space. There's space such that an increase or decrease of one tick represents 1 BIP at any point in price space. And here is an extremely technical chart that I made to visually represent price space. As you can see, top of the chart, like infinite of token 1 in exchange for 0 of token 0, and here the opposite, infinite of token 0 in exchange for 0 of token 1. And these are the little ticks that demarcate price space. So, Oracle data is stored as an observation, which stores 2 details, a timestamp and whether or not something's initialized, that are not as important, or they are important once you're queried them, but the actual data of the price is stored as a tick accumulator and an in-range liquidity accumulator. So something to note about that is that the prices aren't just like, okay, now a token is worth 1, now a token is worth 2. It's a constantly accumulating integer that you have to measure at 2 points and take the delta of, and that gives you the current tick and in-range liquidity. But there's a lot of helpful functions that we made so that you don't have to do that all yourself. Okay, I just covered this. Array of observations, and you can kind of iterate over the observation array and return and manipulate any of that data as you wish in your integrating protocol. Anyone can lengthen the length of the Oracle array, which stores the observations, up to 9 days, which is insane. And I don't know if anyone's done that. Maybe someone knows if there's a 9-day Oracle out there. Okay, so this is a little snippet of what you get when you call observe. We don't have to dive too deeply into this. I just wanted to show it as an example. A tick cumulative return variable and seconds per liquidity cumulative, which is the in-range liquidity. Okay, so this is all groovy, and there are a ton of issues. Intra-block manipulation is the most popular of which, these flash loan attacks, where someone can move the price of something up by 1,000,000%, borrow at some inaccurate price in an integrating protocol, and then push it back down to the normal rate within 1 block. This is something we've seen 100 times before, all throughout DeFi Summer and all of these other things. The way the v3 Oracle works and the way time-weighted average prices work are very helpful at mitigating or completely avoiding intra-block manipulation. But aggregation errors and block spanning manipulation, not so much. So we're going to talk about block spanning manipulation, because it's my favorite one. Okay, so lots of issues that have happened. One that I was, fortunately or unfortunately, in all of the right Telegram chats at the same time during it, was this Rari capital exploitation. This was a quite interesting one. Happened in November. It was like a small cap asset, not super popular, not super deep liquidity. And what happens is someone did a block spanning Oracle manipulation hack. And it was really ugly, really fast. Obviously, this is the hacker that did it. So what was it? Classic thing, right? Manipulated asset price, borrowed inaccurate rates in an integrating system. It was unique because this wasn't intra-block thing. It didn't happen within 15 seconds or within one block. It happened actually over many blocks and was a real mess. So the walkthrough, basically with Uniswap v3, right, you have opinionated expressions of liquidity, which means you can have liquidity concentrated at a certain point, the expected price area, and you can also have liquidity that doesn't exist at some point in price space. And this is, this is what happens when someone tries to take advantage of that, right? They allocate a tiny bit of liquidity at an ultra high price that no one would ever expect this asset to go, like infinity to zero or something close to that. They get the price up, they lose money swapping the pool through some liquidity until they hit zero liquidity, and then it's just free to swap it all the way up into infinity. Once it hits liquidity at infinity to zero, there's not enough extractable value for an MEV bot to swap it back down to normal liquidity because there's no liquidity in that space. So the trade price, there's nothing to be gained from it. And unfortunately, Uniswap at the time, I don't know if they're still doing this, universally disabled on their interface any swaps with greater than 50% slippage. So you literally couldn't go in and manually swap the price back down. You had to wait for a bot to do it or populate the transaction yourself in Etherscan. So in order to illustrate this, I know I just walked through it, but I made this other incredibly technical graph, which is very accurate to visualize price space and how liquidity is expressed. Right. This is, arbitrary token A and arbitrary token B, and how you might expect to see liquidity allocated in price space, right? Not a ton of stuff happening over here, not a ton of stuff happening over here. These assets, no one expects them to go in this area, so why put liquidity there, right? You're an LP, you want a good return, you put it where the prices expect to be moving around. So what happens, there's the spot price. This is zero liquidity space, right? Once you hit the end of this, this should be all colored blue at this point. You can move through zero liquidity space, cross 1,000 ticks or whatever, and pay no gas fees. There's no incrementing gas cost to swap through zero liquidity space. So once you hit here, you're good to go if your goal is to push it to an arbitrary, ridiculous price. This is where you would put a tiny bit of liquidity, like $10,000 or something like that, so that it hits that price and stays there for a few blocks. Incorrect price. Right, so what happens with this? Time-weighted average prices don't really help with this. Rari was using TOPS, but because the price is so outrageously high, an average price of the 30 minutes or whatever preceding this, it doesn't end up helping that much. And here is a examination of what the prices were at every block preceding this manipulation. And as you can see, it should have been $1, and then it gets to absolutely bonkers prices within 1 minute, 30 seconds, something like that, which is more than enough time for everyone to drain your pool. Yeah, tragedy for Rari, sorry. So, the whole point of this, if time-weighted average prices can't help us with block spanning attacks, what can we do? The Oracle library. This is what I worked on. It's so good. Okay, let's talk about it. All right, the Oracle library is a suite of helpful functions that we've written, or people at Uniswap have written, myself included at one point, that help you interact with the Oracle in ways that one might want to. And it's underutilized. So we're just going to walk through it a little bit because it's great. So consult. Pretty straightforward, right? This is how you get a time-weighted average price in a way that makes sense and is easy. You can put this into any protocol you want. You can call one function. You give the address of the pool. You give a time as of a certain amount of seconds ago from which to start a time-weighted average price. And then it calculates from that, let's say 1 minute ago, 60 seconds, up until now, and gives you this time-weighted average price. The price is expressed as a tick, which is computationally efficient, but slightly onerous as far as actually integrating goes. Moving on. Other helpful things. Getting a quote at a tick, right? You have a base token, you have something you want to quote it against it. You can put in the tick that you just derived from consult and return your quote. Super straightforward. Okay, this is where things start getting a bit more interesting. In order to calculate time-weighted average prices effectively, you have to know how long the Oracle array is right now. But because the Oracle array is repopulated once you hit the end of it, like you have, let's say, 10 instances of writable observations, once you get to 10 blocks, it restarts, basically. And then you have a new sort of instance of 10 observations, but how the timing works with that, and there are a little bit of edge cases which are a bit odd. So we made this happy little thing that just tells you, if you want observation as of a certain amount of seconds ago, you can send it to this, and it will tell you how many seconds ago an observation actually exists before you run out. And you can do it in a way that's preserves the atomicity of an Ethereum call, which is great. Similar, or I guess in a similar problem space, if you're worried about returning price and liquidity data at the current moment in time, right? You can't actually get an instance of a data in the middle of a block and include that in your time-weighted average price, because that would be susceptible to the aforementioned intra-block liquidity manipulation scheme. So what you can do is you can get the current price and liquidity as of the first state-changing call in the block and at the beginning of that state-changing call. So before anyone can do any liquidity shenanigans. Super helpful. Okay, so what we're really here to talk about is this one, get weighted arithmetic mean tick. And I think I'm going to go to maybe a little bit later to talk about this. But this is where the kind of concept of aggregation comes in, right? You have multiple instances of the same trading pair on Uniswap, right? Currently there are 4 at different price points, or sorry, different swap fees. And you can query all of those and aggregate those prices together in a way that I will talk about in a second, I guess with my nifty little graph. We'll talk about get chain price in a second. Okay, here we go. Aggregating Uniswap prices. Yeah, this is the good stuff. Okay, so here's an example of a kind of walkthrough of how you would use get weighted arithmetic mean to take all of these pools, right, of arbitrary asset X and USDC, and what you do with them, right? So in this example, you have 4 expressions of the same trading pair. You can call consult on all of them. You get a time-weighted average price of every one of these pools, and then you have this nice little thing that no one does yet, that we can all do, which is analyzing all of these prices and creating delta comparisons or outlier filtering systems, or sort of instances where if there's any divergence between these prices, or if there's some kind of radical divergence between multiple windows that you have queried, right? You can take a time-weighted average price of any kind of window in time of any of these pools, right? So you could do this all twice for each of these and then have this comparative logic instance where, you can say, has the time-weighted average price of the last 30 seconds diverged sufficiently from the price of the last 5 minutes, or a window of 5 minutes that ends right up until the last 30 seconds. And you can just end your transaction, right? You could put like a break on your liquidity protocol. You can do a bunch of little safety mechanisms. If that doesn't happen and everything is functioning as it should, you can use this get-weighted arithmetic mean tick, and what it will do is it will create a weighted mean of all of these prices and weigh it by the in-range liquidity that exists at the time of you calling consult on all of these pools. The benefit of that, in a sort of simple way, is that if one of these pools is trading at an inaccurate price, one will expect it to be trading at an inaccurate price with relatively little in-range liquidity, right? And if there is little in-range liquidity at that inaccurate price, it will get weighed out, basically, of the average price that you get from aggregating all of these. Will it get weighed out entirely such that it has absolutely zero impact? Not necessarily, but it'll help. Let's see, where are we at? So I think that's most of it. Okay, so this is the kind of cutting-edge experimental implementation of this kind of atomic delta comparison system. This is not in production yet. It's published. It's in the public Uniswap protocol code base. Noah Zinsmeister wrote it. It's called the Oracle Slippage Contract, and it essentially does exactly what I was talking about. Right? You send in an amount of paths, pools you want to swap through, and a certain number of amounts, and a certain seconds ago. It queries, it returns 2 windows, right? A window, as of a certain amount of seconds ago, and then the current trading tick. Once it has all of those, it creates this weighted tick data array, compares the current tick with the synthetic average tick that was created while querying this wide window of array data, and then compares the synthetic ticks with the current one, and fails in the next transaction. You can see here, it will fail if the synthetic current tick is beyond a given delta that you pass in as an input parameter. Basically, the goal being atomically protect your transaction from a certain amount of slippage. Anyone can use this right now to assure that their transaction, if they're just going to swap a huge amount of liquidity and they don't want to get front run or sandwich attacked or whatever, you can ensure it on-chain by calling this function, which is great. But you can also use this in the context of a lending and borrowing system or some other more sophisticated system to create a kind of speed bump for any shenanigans. Yeah. Oh, one last little thing that no one seems to know about. Get chained price. An interesting thing of how ticks work in Uniswap is that you can query the price of an asset independent of what trading pairs actually exist actively on Uniswap. So if you have arbitrary token, whatever, that's a wrapped version of token, let's say, okay, there you have a trading pair token A and B, and then you have a token B and C. Then you have a wrapped version of token B, which is only supposed to be trading against token B. You can call get change price and get this very elegant way of expressing token A in terms of this arbitrary wrapped token B or any other thing by chaining the price through an arbitrary number of pools without like compounding price risk or something like that. It's beautiful. It works flawlessly. Well, I shouldn't say that publicly. It works flawlessly as far as we know for the current time being. Back to the aggregation, back to the liquidity weighing of time-weighted average prices. This is basically it. Yeah, Oracle slippage. Where do we go from here? Okay, so these are the takeaways. Basically, the Oracle library and the current implementation of Oracle slippage is sort of the state of the art as far as Uniswap is concerned. This is all public code and will be open source as soon as the business source license expires in about a year. Although I think the Oracle data is actually already open source. Regardless, it's visible, you can use it, and you can take it further. And I think anyone would be happy to see any kind of experimentation in the areas of aggregating prices or creating sort of, stops or logic breaks around price divergence. Obviously, we're all here discussing these kind of things. So yeah, that's it. Key takeaways, basically what I just said. No standard expression of Oracle data, so aggregation is difficult. Here's a beautiful opportunity now that we're all here to talk about standardizing Oracle data. It would be a miracle if we managed to do that. I would love to see it. Yeah, because of that, fallbacks and temporary lockouts are a better near-term solution. This is my own opinion. The V3 Oracle library is super effective and very underutilized. So if any of this seems even remotely helpful, I would take a second look at it because it's super powerful and really, really great. And if you want to look at kind of the cutting edge and see if you can experiment at all and push it a bit forward, Oracle slippage, which is in the similar repo to the V3 Oracle library, whatever. It's all on GitHub. You can find it. It's available. Yeah, there you go. That's it. Boom.